Okay, so this is for strictly advanced chemistry. So this is talking about the principal quantum numbers. Or the quantum numbers, not necessarily just the principal, but talking about the quantum numbers. All this is going to allow you to do is to give me the exact address of any electron that I ask you for. So it's made up of 4 different numbers. You have principal quantum, which is your n, and it's the shell which coincides with the period of the periodic table. So your principal quantum number is going to be 1 through 7. Just depends on what shell it's in, what period it's in. Then you have your secondary quantum number, which is by L, and it divides the shell into subshells. So it has a letter designation and a specific electron cloud shape. So here are your L's. This is the letters that correspond with it, S, P, D, F, and each one can hold so many electrons, and it has a certain shape. So we already went over this in the other video. Then you have called a magnetic quantum, and that's the subshell. So that's taking these, and it's
Juliana McKnight, please come to the front of the school. Your ride is waiting. Juliana McKnight, please come to the front of the school. Your ride is waiting.
So it is then going to take your subshells, remember SPDF, and it's going to split them into individual orbitals. And it's based on all of this stuff, which just doesn't really matter, but it's going to split them up into individual orbitals. And remember, we talked about that on the other video when I said, okay, you got SPDF. S can hold 2 electrons, so it's got 1 orbital. This would be your magnetic quantum. This would be your ML. Okay. Then you got 6 electrons, 3 orbitals, 10 electrons, 5. All those are going to have an ML number. That's what that's talking about. And then last but not least, your spin magnetic quantum, which is MS, is talking about your electron spin. And we give those values of either positive a half or negative a half. It just depends on whether your arrow's up, your electrons point up, or your electrons point down. And the only time you know this is when you look at your orbital notations. So then we had this fabulous chart here. Remember that we said for your ML, it's your number of orbitals. So in N1, you can only have a single subshell, and that would be 0, the letter or the number 0, which corresponds to an S orbital. Okay. So you can only have one orbital. You always give the middle one 0. You can hold 2 electrons. In your second subshell, you can have a 2s. You can also have a 2p. So that's 0 and that's 1 because this is your s, that's your p. So 0 means you only have 1 orbital because that's your s. Your p can have 3 orbitals. So 0 goes in the middle. Then you just do negatives on the outside to the left, positives on the right. When you get to your third shell, you can have S, P, and D. When you go to your fourth shell, you can have S, P, D, and F. All right. So just remember when you're looking at your orbitals, 0 is always in the middle. So what does this mean for you? Okay, all this means for you, since we have now covered electron configuration, okay, let's say I want, for oxygen here, I want to know what the address is of the last electron. So that's in a 2p. It can hold 3 orbitals, 0 in the middle, -1 on the outside, +1 on the inside. This is how my electrons look. My last electron is this one. So I'm looking at oxygen, so that's 1s1, 2s2, or I'm sorry, 1s2, 2s2, 2p4. So 2 is my highest number, so that's my N. My L is my shape, and it's P, so SP, so 0, 1, so that's going to be a 1. My magnetic number is which orbital is it in? It's in this one, so it's -1. And my magnetic spin says, okay, it's pointed down, so it's -1/2. And that's all you're doing is just giving me ML, ML, MS. So that's the only extra step you have to go. But you can't really do this until you get to orbital notation, which is why we haven't practiced it so much yet.